Good morning, everyone. Today I'm going to teach you one optimization algorithm, which is the most basic optimization algorithm and stay useful. All right. It is called a greedy algorithm. I really like the idea of greedy algorithm because greedy algorithm makes local optimal choice at each step. All right, with the hope of finding a globally optimal solution. What does it mean? Okay. So when a greedy algorithm search, all right, it doesn't calculate for the whole possible pathway. It just step with each step, all right. So it just step with the making a local choice at each step. Okay, all right. So how does it work? Let's see with the example. So here I'm trying to find a pathway which give you the highest number. All right. So we are not very sure what is in the next step. We can see that there are two steps, and then there could be a three pathway that we can find. All right. So of course, the best way is to find the weightage for each possible path and then get compared, right? But it's not how greedy algorithm works. Greedy algorithm focus on each step. So looking from the six, they have two options, 3 and 4, right? So 4 is greater than 3, so it will choose the pathway of 4. It will choose the number 4 node, all right? So now number 4, it needs to choose again between two pathway. Okay, let's see what are the answers. Right. From the 4 itself, when you look at it, there are 14 and 11. So it will choose 14. So by using a greedy algorithm, our path is 6, 4, 14. All right, 6, 4, 14. Okay. So the total sum is 24. Obviously, it is not the global optimum because if you have chosen the number 3, all right, 6, 3, then your next node is 20. So in the whole pathway, you will get 29 if you have chosen the 6, 3, and 20. So 6, 3, and 20 should be the global optimum. All right. But greedy algorithm always based on the local optimal choice. So greedy algorithm is simple, easy to understand, but it may not always give you the global optimum. All right. Okay, now let's look at the another example where it provide you uh, how to find the pathway with the lowest weightage. All right. Now here I want to go from A to F. So the number that given show the weightage of the pathway. All right. So we can consider here that is the challenges. Okay. Heavy number, a bigger number means more challenges. All right. So we want to choose a lower number here. So our optimal is the lowest. So for the greedy algorithm, from A, he has two paths, 4 and 2. 2 is smaller than 4, so they will choose a C. It choose to go to C. All right. Then from C, it doesn't have any other choice because it cannot go to B, it can only go to E. So it will go from A, C, and E. All right. Then from E, likewise, it has only one choice to go to D, and from D, you have only choice to go to F. So the only pathway that you can go here is A, C, E, D, F according to the grading algorithm. So if you compare all the weightage, it gives you 20, 2, 3, 4, and 11. All right. So what are the other possible option here? Other possible option will be A, B, C, E, D, F. A, B, C, E, D, F. So if you look at on the pathway A, B, C, E, D, F, total weightage will have be 9 plus 3 is 12, 12 plus 14 is 16, 16 plus 11 is 27. It is stay is higher than ACEDF. All right. Then another possible pathway is ABDF. If you go by ABDF, also it takes 25. All right. So in this example, greedy algorithm give you the both global optimal and by choosing the local optimal choice. All right. Okay. So let's see another example of greedy algorithm. So here you have the set of quants. All right, $5 coin, $2 coins, and $1 coin. And you want to make $80 using the coin, but you want to give the smallest number of coin. All right, so how does it work? We will start with the $5 because it's a local optima, right? And then 521, you will start with 5 because it's the biggest. So after choosing the 5, the next coin that you should choose is also $5 coins. We only have 10. Another coin that we will choose is also $5. So we will have three $5 coins. All right. Then the fourth coin, according to the greedy algorithm, you should choose 5. But here, if you have four $5 coins, you have 20 in total. So which is greater than your goal, which is 18 only. So it will select between 2 and 1. All right. So among 2 and 1, it will choose 2. So you have 17 now. All right. Then the next one, you cannot choose 2 anymore because it will be more than 18. It will exceed 18. So the next one that you are going to choose is 5, 5, 5, 2, 1. All right, 5, 5, 5, 15, 17, 18. So you need 5 coins. Right. So that is the best optimal choice you can use. Okay, you need at least 5 coins to make $18. Okay. Of course, there are times that greedy algorithm fail to find the global optimum because it just makes based on the local choice. So here, the example that I have picked up to share with you are coming from this textbook, Discrete Mathematics and its application 7 edition 2012 by Kerner. Right? So for more example, you can always refer to this reference, and I would like to give credit to the author for sharing their knowledge. Thank you very much. That's all for these videos, and the next videos we will be talking about the time complexity and bit O notation. Thanks everyone.